Hello again, YouTube. Thank you for tuning in to another episode in Dave's Garage. Nice and gentle episode today. I'm still on doctor's orders to be good, and I'm still being good, although a little bored. I'd like to start off by saying a huge thank you to all the kind comments and support that I had from you guys. I couldn't really reply to everybody, so it's just simpler to say thank you to everybody en masse, sort of thing. I had hundreds of messages of well-being and good wishes, so very much appreciate that. It's nice to know that there's so many people out there that care. It's heartwarming, so thank you very much. Okay, so for this episode, like I said, something a little bit gentler. There's a lot of videos out there on YouTube land about car wiring, and they seem pretty complex to me. Looks to me like they overcomplicate what is essentially fairly straightforward. Now, I am of course talking about classic car wiring, because modern car wiring is a different kettle of fish altogether. Why we need a computer to run indicator systems, that's just beyond me. So this isn't about modern car wiring by any stretch of the imagination. This is for simple stuff like the Escort here. So what I want to be demonstrating, just with some simple bits and bobs, how you can get your head around classic car wiring or even kit car wiring that's not nearly as complicated as you might imagine. You see a massive cables and a wiring loom, you probably throw your hands up in the air and think, oh, what am I going to do with that? But hopefully I'll demonstrate that each section of the wiring is effectively a bit by itself, and there's just lots of bits by itself all bundled together into one loom. But essentially each circuit is power, fuse, switch and load. So that might be as simple as a light. So power from the battery through a fuse, through a switch to make or break a circuit, to a light bulb, then back to earth to bring the light bulb on. Essentially all car circuits are pretty much just that. I hope you enjoy and see what you think of it. Right then, so the simplest circuit you can have is a straightforward run through. So there's your live from your battery. I've used brown as a live. Lucas colours tend to be brown, live, black, earth. But that's not to say that all manufacturers are like that. Some like it the other way around. Some manufacturers like black to be live and brown to be earth. But stick with Lucas colours for now. So simplest circuit you can have is straight bulb to earth. There you go. Simplest car circuit you'll get. Of course, you're not going to generally have that because you'll want to switch it. Now, bulbs tend to be switched live, but it doesn't matter. You can switch them earth, switch them live, doesn't really matter. So, simple switch in the circuit. Let's get a bit of a cable here. So if we put a switch in between that, so this is just effectively one piece of cable with a thing in the middle, a split off in the middle. So if we effectively break into that circuit with the switch, now you have a switched circuit. Now this is the basis of pretty much all automotive electrics, the simple stuff at least anyway. There's power to a switch, switch it on, switch it off. Now that could be, for example, your ignition switch. So power into your ignition switch, and that's your ignition live. So ignition on, then to start, ignition off. Now this is a very basic ignition switch, something you might use on a kit car, for example. So usually you have three. You have ignition on, accessory, then start. The accessory will tend to go off. Now we could wire up a bulb for the start because we have a spare one. So if we piggyback the earth with it. And earth that bulb. And if we put this onto on this ignition switch, we've got the start out there. So that would be effectively a starter. So then you'd have ignition on, start, ignition off. And that's your very basic, ignoring the alternator side of things, because that's a different level altogether. I do have a separate video about setting up an alternator. I'm trying to keep things dead simple. So there you got power to the inlet side of the ignition barrel. Switch, and all this is a switch. Switch to ignition on, switch to starter motor, and that then would be spinning your starter motor around. Of course, your ignition on would live up your ignition circuit through your distributor. Ignition off. But again, all that is a switch. So, and that's pretty much the basics of all automotive electrics. Right, let's get this back down to basics. Now, of course, you'll want to get this off of it. Now, sometimes you'll want to power up to something a bit more powerful, like a spotlight, for example. So again, very basic circuit would be like that. Now that's drawing a good few amps, that is. So it would be wise to put that through a fuse. So we have a fuse here set up. We've got 10 amp and a 5 amp. So we'll stick with the 10 amp. So we'd run the of course, this would be running through your ignition circuit. So once you've got ignition live, you'd run that through your fuse, from your fuse to your bulb, and then that gives us a fused high draw. But of course, you want to switch it. Now you can, of course, switch it by putting a switch simply from there to there, and that will switch that on and off. So that, imagine that would be like your full beam. But this switch, if I leave that on for long enough, will start to warm up, because that's not designed for high draw current. So what you'd really want to do is use a relay. Now if we break this all back down to basics again, get that out of the way. Now, a relay is a really useful bit of kit. Again, really is just a switch. On the sides of the relays, I'll get a photograph and put this up, but on the side there, it tells you what the relay does. Now the way the relay basically works is it's electromagnet inside. So as you live it up, you'll hear a click, and that's electromagnet. So let's do that. 1 and 2 is our, now these come all sorts of numbers. Sometimes it's 85 and some what have you, and this has got 1, 2, 3 and 5. But the plan to them is almost always printed on them. Also, it will tell you what ampage it's rated at. So this is 12 volt at 40 amps. So this is a nice chunky relay. Okay, so 1 and 2. So if I put live to 1, if I earth that, hopefully you hear that clicking. And what that is doing is connecting those two together. So those two, 1 and 2, pull the electromagnet together, which makes a more powerful switch, and those two can take the 40 amps. So these can be run with almost no amperage at all. Just this will only pull about an amp or so, if that. So this little switch, which will only pull a couple of amps itself, will be perfect for that. So what we can do, and these generally are earthed, so usually you'd have your live going to it. That's got a bit floppy, let's just tighten that up a bit. So you have your live going to it, then earth coming away from it through a switch, and there you can hear, hopefully, that clicking on and off. Okay, so what we want now is a live going through here, so we can just piggyback this live, because if you use the correct size cable to take the amperage you wanted, you can just piggyback the live over onto there, and that'll give us a live out from that terminal there, which will be our powerful live out. So all we need to do now is earth that, so we get a piggyback earth on there somewhere. Piggyback that earth. No, we want to piggyback the other side of the earth. Hang on, bear with me. We want to piggyback that side because you want a constant earth. Ooh. So this is effectively just putting an earth straight back to the battery. Now in your car you'd have a buzz bar for your earth, so all your earth to go to the back to the same point. So this would be the one to go to there for the switch, and this would just basically be our earth for the light. Now what we got going on now is the power for the bulb is actually coming through the relay, and the switch is just turning the relay itself on and off. So I could leave that on constantly now, and that won't get hot, because there's hardly any amperage going through there. All the amps is going through the relay, and that's what you'd want. Now, of course, if you wanted to fuse that, you put a fuse between there and there, feeding your relay, and that's that circuit. So that's pretty much how a relay works. Really simple and really useful. Now, my Escort doesn't actually have any relays at all in the wiring circuitry, but I'll be adding some of these just for a bit of security to make sure we're not melting down the old switches in the car. Okay, let's break this down to basics. Get rid of that. Now the other thing is brake light switch. Okay, again, pretty simple. These tend to be switch live, so if you put that through there, there's our bulbs gone. Send that to our bulb, and our bulb to earth. You'll see this will come on straight away, because that's how brake light switch works. When it's like that, it's open. So this will pull on your brake pedal. So your brake pedal is effectively like that. So when you press it, it lets go. So that's pressed up against your brake pedal, like that way around rather. So that'll be get this. That'll be your brake pedal, like that, coming down to your pad. When you press on it, it pulls away from the switch, and that's what turns your brake lights on. Again, all pretty simple, and again that'll be run through the fuse. Okay, so let's break that down. Now the next one, which tends to fox a few, is indicators. This again is fairly simple. So what you need is a special relay for this. There's a few versions of these types of relays, but they essentially do the same thing, which is turn power on and off. And they're marked. So this one's marked positive, negative, and live, or L, or live out. So if we do this very basically, connect the positive to the positive, negative to the negative. Let's do that. Let's piggyback that because I need a supply for the negative for the bulb. Just piggyback in the negative, so I've got a negative for the bulb. if we run a positive from the bulb, we've got brown one there, to our relay, we have a flashing bulb. Now, of course, you want to run this through a switch, so, and a fuse, of course. So, presuming this is a fuse supply, let's start this again. So, you'd run your power to the positive on there, and to the negative, and then you'd run your power through your switch. Power there. So coming from your live out, you would then run to your indicator switch. And this effectively will be an indicator switch. So in the middle, your power common goes to there. And when you switch it, that one will live up or that one will live up. But of course, now that this is coming through the indicated relay, it's going to be a pulsed live. Back on there. And what we can do is, let's get two bulbs rigged up with earthed bulbs. Now for you, run a live from one side to one bulb, and a live from the other side to the other bulb. What you'll have is indicators. So right hand indicator effectively, left hand indicator, or right hand, left hand from the way you're looking at it. So hopefully you'll see what's going on there. You've got a live coming in from the relay, which is pulsed, into the center, which is a common for our switch, and the indicator stalks are pretty much the same idea. Center, that's off. So it sends that pulse signal then to that lamp or that lamp. So if we took the indicator out of this equation and just run that straight from the battery, you just have constant supply. So that, all that does is that simple relay there is give you your pulse. So there's a few versions, like I said, of this. Some are 2-spade, some are 3-spade. I prefer the 3-spaded ones because they tend to be a bit more accurate and less prone to issues. And if you're running LED bulbs, you'll need a special electronic one of these because the LED bulbs run differently again. Okay, so the next thing I wanted to show you was the different bulbs you can get. So you'll notice this is a stop and tail bulb, and in principle the high and low beam works the same way. So if we run I don't have bulb holders for these, unfortunately, not a hand at least. We can bodge it. So if I run that into there like so. So and I'm going to do this sort of, well, you could do it the other way around actually. Do it the proper way around. So yeah, outside of the bulb is always earthed. So if I press that onto there, that is how the bulb holder would work effectively. We need to get a bear on there as well. So if I hold that, and 12 volt is not going to kill you. See, I can hold both ends of that battery, and there's a 300 amp battery or whatever it is. It's safe. It's not going to hurt you. So don't be afraid of electrocuting yourself with 12 volts. Okay, so on the back of these bulbs, you'll see there's 2 contacts. In the bulb holders, you'll see there's 2 contacts to suit that. And these generally have either 2 or 3 wires going to them, depending on the type of bulb holder. So So your earth always on the side. If I live up on side, that's your tail light, and that's your stop light. And in essence, like I said, the main beam works the same way. So that would be your dip beam, that would be your main beam on a headlight bulb, but obviously a bit more powerful. And this is a standard bulb. You'll see, so you've got the one thing on the back. Works exactly the same way. Earth, the shell is always the earth, although it doesn't matter with the bulb which way around you run it, but the shell is always the earth. And there's your basic on and off. Now to show you it doesn't matter which way around, it can run the positive to the shell, and the incandescent bulb doesn't really matter which way around you do it. LED bulbs do, and you can actually destroy the LED bulb the other way around. And one last thing I wanted to show is momentary button. So this would be like a horn button, and this just works like an ordinary switch like I showed you earlier. Whatever that's gone there. But instead of clicking over, it just presses momentarily to make the circuit. So effectively, if that was a horn, that button effectively just does presses on and off, like so. And that would be your horn going up. That would effectively be our ignition switch. On, off. Oh yeah. Ignition off. Big red cable going to battery positive, and that would be our charging circuit. And then the blue wire there goes to our ignition lamp on the dashboard, which excites the alternator. Right, okay, so the next thing to demonstrate is gauges. So what I'm going to show you is basically how the pickups work. First of all, or thymistors, I think is the proper term for them. So this is a water temperature gauge, typical aftermarket sort of thing you'd have in a kit car or a dash and make yourself up. So what we have here is a cup of hot water, which is, let's put the temperature probe in there, which is around 70 to 80 degrees mark. So we'll leave that in there. Normally it's going to be out of the way like that. And if we drop that in there, just so that'll warm up, you'll see, hopefully on the camera, so we're on ohms reading, and what you'll get, if you pull this out of here, so we're currently at 74.8 degrees. I pull that out of there and take a reading between there and the body, which would be Earth. You'll see, if we get the let's change that to a bit more sensitive. You see we have an ohms reading, and as that's cooling down, that's changing. So you see the reading raising as that changes. So what that means is whatever the temperature this sensor is at, it gives a different ohms reading. And essentially all gauges work the same way, whether they're fuel level gauges, temperature gauges, air inlet gauges, they all work pretty much the same way in essence. Fuel level gauge works by moving two wires really across a coil of wires, and the resistance changes across those wires going to where that level is. A bit like the old Skeletrix controllers. So if you remember how they work, you pull your lever, the harder you pull it, the faster the car goes. But if you let it go, the resistance changes, so the motor gets different sets of power. Essentially, this works the same way. So as that's cooling down, you'll see the resistance changing in that. So you'll see our gauge here. We've got different setups on here. So we've got a positive, negative, and S, which is signal. So if we set this up now, so positive wired there, negative, which is connected to the wrong one here, negative wired there, I've also wedged in the light a little bit, just roughly. Get it in there. There we go. And our signal wire there. So we can get the gauge pointing in the right direction. Hopefully you'll be able to see what's going on. So this would effectively be our car bodywork, or the engine body, because as that's screwed into your water channel, it'll earth on the water channel. So that's what that's doing, earthing the body. Then our signal wire is coming out of there. So we got that is showing a reading of 62, and our gauge is showing a reading of about 60, which is thereabouts accurate. So you can basically see how the temperature gauge works. So if we pull that apart now, pull that out. You'll see how the reading has changed now across. So you see, hopefully you'll see the multimeter reading now 1.11, 1.12, which is a fair bit higher than it was reading just now. And as that cools down, that'll go higher. So based on the resistance is where the needle points. Again, pretty simple. Now usually the gauges will be a regulated voltage, because your battery voltage changes, of course, when your alternator kicks in and out. If it's a 12 volt meter, they'll need regulating at 12 volt, because if it's receiving 13 or 14 volts, which sometimes you'll get with the alternator kicking in, they'll mess up the readings on there. So it needs a regulated reading. I'm not sure whether these aftermarket ones come with regulators built in. They may well do, but it wouldn't hurt to have a regulated feed to it, and that's easy enough done with a regulator. In essence, that is vehicle electrics. It isn't more complicated than that. It looks complicated because when you pull a vehicle wiring loom apart, there's cables everywhere, and it looks like a spaghetti junction. But each cable is just its own circuit. Every circuit generally are split. Sometimes you'll get your fuse board, which is effectively what this is, but only just two. So you'll have a common live going into them. So that's coming from your ignition switch, for example. So ignition on. So that'll be broken through your ignition switch, and that effectively would be your common live on one side, and your fused earths coming off the other side. The fused lives are coming off the other side, and they will be your ignition live circuit. As it is like that, straight from the battery, which some are like that, that would be your constant live fuse circuit. And some circuits are straight off the battery, and they are just unfused constant lives. But there's no more to it than that. So if you're worried about wiring up a car, don't. Just take each circuit one at a time, and imagine what you're wiring up is just like a light bulb. So even if it's a starter motor, a horn, a washer system, essentially they all work in the same way. So I hope that's helpful. I hope that's kept it simple, because there's lots of videos on YouTube about wiring cars, and they tend to have piles of wires everywhere, and it can be a bit confusing. But if you look at each circuit as its own individual circuit, it's a lot simpler. And once you put all those circuits together, then you end up with a wiring loom. And generally with cars, one colour cable does one job. You look at the Lucas wiring, for example, I think it's white, is an unswitched live. I'm going from memory. So every white cable then, after it goes through its switches, so it would generally go to its switches white, and then it leaves the switch white with a blue trace or green trace or whatever trace, to show that it's going somewhere else to do something else. So for example, if we were running this to a switch there, and from the switch would then generally be so that's brown there, that would be brown perhaps with a red trace. as it goes off to the bulb, and with that. So generally, this is why you have traced wires. So your main power cable will be generally a solid colour, and then as it's become switched, it tends to be traced. But that helps with trouble finding. But every cable has its own specific job. So if you have a wiring diagram for your car, if you find the brown cable with the red trace in a wiring diagram, that generally only has one job, or at most two jobs, sort of thing. So, but it helps keep everything separate. So I can't stress enough, each circuit, look at it by itself. So for example, if you've got a problem with the right hand indicators on the car, look at it as that one circuit going from your indicator relay, which is most likely going to be your problem, through that. Just so follow that one circuit through methodically until you find out what the problem is. Don't get overwhelmed by, oh, there's so many cables. Each cable does its own job, and it really is as simple as that. Hopefully you found that useful. Like I said in the video a few times, keep each circuit independent of each other in your mind, and that makes fault finding or building your own loom that much simpler. Now, of course, I haven't included modern electronics and all that stuff for modern cars, because that's a whole different level, and that is complicated. Like I said earlier, using computers to control indicators, an indicator circuit is simple enough. I just don't fathom why you'd want to do that. Possibly because it's more likely to go wrong, and then you'd have to buy another new car. But that's I'm not going to go down the whole conspiracy theory about obsolescence built in, because I'm just not interested in that. It's the classic stuff that interests me. I also didn't include about the wiper. I did try looking for the footage of me doing the wiper motor, but I couldn't get any part of that to look obvious enough as to what it meant. So it's probably easier just to look back on the previous videos to see how I worked out how the wiper motor worked with the park mechanism and the special sort of switches you need for that. So I've stuck very much on the basic stuff, managed to squeeze in a bit there about the alternator, so hopefully that made sense with the little bits I scavenged from that old video there. So once again, thank you again for watching. Thanks again for all the messages of support. I am feeling a lot better. I'm on meds to kill off the infection, so and that is working, believe it or not, even though I'm still coughing a little bit. But I am much better than I was, so I won't be long now, another week or so, and I'll be back in work and back firing on all cylinders, hopefully. So keep an eye out. I may do a video about 3D printing. Somebody has mentioned that they'd like to understand a bit more about that, about setting up 3D printing from scratch and showing what I do with it, which is really, really simple. I keep it really simple. I like simple. I don't like to overcomplicate things. So I may do a video on that. So let us know your thoughts, whether you'd like to see that. Well, see you next time.